Okay, OPM 2000, here we go. This is week 5. I'm having a bad hair day. And since I don't really have hair, so when I have a bad hair day, it's going to be down here on my chin. Anyway, it's a little curved. I took a nap earlier and I woke up, this thing was all crooked, so I had to try to straighten it with I got this heated brush. And anyway, long story short ending, yeah, I've got all the little doodads like that because when you got hair like this, there is maintenance to it. It's not as easy as you would think. Anyway, not that you really wanted to know about how I take care of my goatee, but anyway, now you know. This week, week 5, we are jumping into the getting into the nitty gritty of operations. So let me get back up here. I'm going to be posting my slides earlier in the week. What I am going to say is that they are a work in process. I am going through, I did some work on them today to update them for this particular course. Because remember, this course was rewritten over the summer. So I'm trying to update my slides. Um, there may be more changes coming to my slides, but it's really not going to affect where you're at because it's going to give you more information, not too little in the way of information. Make sure you do the readings in the actual module, which I do use them as the foundation for my slides. And then I bring in additional sources to further substantiate my claims or to go into some areas that are deeper. There are some equations in my notes this week. And bear in mind, this class isn't all about the math, but it's nice to know why the math is there and what the math is based on. You're going to learn about Little's Law. Little's Law is actually used in operations in many different capacities. It just takes rearranging the way the equation is laid out. And you can use Little's Law for a number of things. And we're going to talk about that. You're going to see that in my slides. You're going to see that in the presentation over the next couple of weeks in the presentations. Um, but this week, um, you're going to be dealing with manufacturing, the nitty and gritty parts of it, okay? Work centered. A work center is comprised of workstations. And workstations, these are areas where workers use the various machines or tools or the equipment to carry out the function that they were hired to do. So this is where you're going to find the die cutting machines. You're going to find the die cast machines. You're going to find the CNC machines. You're going to find each one of these is going to make up a workstation. So when the item comes through, you're manufacturing an item. When it comes through, it goes to your station. You might put it through the CNC machine, and then you pass it on down the line. It goes now into another process. Okay. It might need paint. It might need to have the surface refinished. It might need different things like that. Each one of these is a workstation. And a workstation usually has an employee that works there. And they run the software, they run the program, they operate the equipment, they bend the metal, they press this, they do that, and they do their function and it gets moved right along. They are a part of the process. They're making a refrigerator collectively. Individually, they might be working on adding wiring to the motor. Or they might be putting the solenoids into the motor, or they might be doing this or that, or maybe on a car, they might be pressing out the fender. So everybody's got a part to play in manufacturing. So you're going to be learning about that. You're going to be learning some definitions. Raw materials. What is raw materials? Well, it is the supplies that we get in that they've not been worked on by us. We receive them, then we process them. It could be raw rubber. It could be aluminum ingots, which is how aluminum is usually transported, sold, and shipped around. It's in these ingots, blocks of aluminum. It could be in steel rods. It could be in blanks, steel blanks. Whatever it is, we are getting that. That's the raw material. Then we work on it here in our factory. We process it, and we have an end item, and that's what we put into our warehouse or send out to our distributors. That's what now moves down the supply chain further. Supply chains have suppliers. You've got the manufacturers, and you might have a couple manufacturers in the row, depending on how that particular supply chain is organized. Then you're going to have distribution network. Then you're going to have your retailers, and then you're going to have your customers. So when we get the raw materials, there is no end item. We make the end item, which is what we either put into our inventory in our warehouse or we send out automatically to our distributors, and it moves down the chain. So if we're making motors for a refrigerator, that is our end item. The end item of the entire supply chain would be the refrigerator. But only what are we putting out of this plant? When I was at Samsung, when I worked there, the end item was they were microchips. And they had all these huge fabrication units. They had four fabrication units, and they were like a department. You had the etching department, they had the this department, that department, and they do this process and they make this little microchip. And they would send out, at my time, 20 years ago when I was there, $4 million a day of product would leave that plant in a huge semi truck that was 98% empty. And they would have one box in there with $4 million worth of microchips. And that would head out to the next step in the Samsung supply chain. We fulfilled our end of the end item we're supposed to make, and we sent it on. So, yes, that's kind of a supply chain talk and a little bit about what we're doing with raw material talk. Components, this is what the piece is called after we've worked on it. So, once we get the raw materials and we start working on it, it now becomes a component. And that component works through our manufacturing process and it ultimately becomes an end item. Um, I'm going through seeing what else from my notes I want to talk about right now. Um, a job. What is a job? Is it just where I go work at? Okay, that's one definition. Another one is I'm a customer. I call up the factory and I say, I want to put a job order in. And I put in a job order for 10,000 spark plugs. That's a job. Now we receive that job order and we create the job around that. Okay, the job order creates the job. Now we got a job. The job is we're just supposed to make 10,000 spark plugs for XYZ company. Next week, we might receive a job order from the ABC company and it's for 15,000 spark plugs. So the job is what we're working on right now going out to that customer. Um, and the customers, they put in the orders, they generate the orders. You're going to learn about cost of goods sold. You're going to learn about capacity. What's capacity? Well, this refers to what what's the maximum our production line can produce. That's capacity. You've got to know these things, capacity. If we're going to figure out a bottleneck issue or we're going to figure out the throughput equations, we got to know what is our capacity. So these are where the numbers come into play. Um, Work in process, a WIP. You're going to see WIP a lot for the next number of weeks, and that is WIP. WIP stands for work in process. The raw materials come in, goes to the first workstation, it now becomes a WIP. It is a work in process. It is a job order that we are fulfilling is each step along the way. It's a work in process, a WIP. So when we want to know this item in our WIP, we want to know how many items are in our actual manufacturing line for that job order at that moment. That's the WIP. There are equations to figure that out. Um, you're going to read about inventory turns, inventory ratios. Such exciting time. I know a turnover ratio. Um, this deals with the throughput. The throughput is normally considered on a yearly basis. So when we figured our throughput for our production line, we're not looking at the throughput for today. We're looking at the throughput for the year. Now we can divide that down into quarters, months, and even days and have an understanding where we're at and if we're being efficient or not. But the throughput is going to be a yearly number. Um, and it also deals with inventory. When we're looking at inventory, we're counting with the end items we have in our warehouse. If we have a warehouse, we're going to look at all the WIP. And when we look at the WIP, we're looking at the throughput. What is in the process of being considered the throughput? It comes in, now it's going through our production line, and it comes out as an end item. So the things that are in that process, that's the WIP. This is where we're going to start getting our turnover ratio. We're going to know what that turnover ratio is. We're going to be able to identify if we're being efficient or not. In a warehouse, all inventory is FGI. And I've got to remember 1 second here. I'm going to pause this 1 second. Okay, you really don't need to worry about that. That's in my notes. My notes go deeper than what you really need. It's going to give you extra information. So let's move on here. Cycle time. Cycle time. This is also known as the average cycle time. So you have cycle time, CT, or average cycle time. It's also known as flow time, throughput time, or sojourn time. The sojourn, a fancy word meaning travel. So the time it takes for an item to enter our production line, what time is it that it goes through and finally exits? What's that time? Bump. Now we've got the cycle time. One cycle. Cycle time refers to the average time between the beginning and end of a job. And remember, the job is the customer order. So the 10,000 spark plugs or 15,000 spark plugs. So we've got to know what is that going to be, the cycle time during that production. How long is it going to take us? And we're going to turn to Little's Law for these. Lead time. A lead time, it's something that managers see as being consistent. And this is the time provided to produce a specific part. The major difference between the lead time and the cycle time is that while lead times are consistent, cycle times are random, but both are necessary in calculating the service level. So, as a manager, we want to calculate our service level. We've got to have our lead time, and we've got to have our cycle time, and we got to understand. Okay, the lead time we see that as a constant, and we see that the cycle time is not. I give you the formula here for service levels, utilization rates. Okay, we get into bottlenecks. Now you're driving down the road and suddenly there's traffic. You get past an accident and now there's no traffic. You just experienced a bottleneck. On our production line, we got the items coming through. We got each of the products coming through. We're working on assembling it. We're doing this. And suddenly it gets backed up at workstation number 12. And workstation number 12 is slowed down. So that means 11 all the way down to 1 gets backed up. But that's not just it. All the workstations in front of workstation 12 have to slow down now because they're not receiving the items to work on. And so there's a delay being caused. And yes, bottlenecks, there's an equation for that too. And like I said, I give you these equations, but follow what's in the module because I believe they reduced some of the math in this course, which I'm happy to see. Math is important in operations, but this is an introductory course. You don't have to go through and understand every little thing about Little's Law at this point in time. Um, okay, I already said that. Let's move to the next one. Other things you're going to look at, like I said, bottlenecks, raw process time, the critical whip level. These are all going to make sense after you read the material for the next few weeks and look at these slides. These slides that I'm giving you now are something that you're going to be able to turn to for the next few weeks to hopefully guide you as you work your way through operations. Now, since there is no lecture component in this course, I'm not going to go into great detail in each one in this video. This is just kind of a little introductory video to help you get started for the week and to introduce the topics. So we're going to end the video there, but the last thing I do want to point out is that where's that? Okay. There are 5 different types of manufacturing. We have bespoke, and bespoke, that is almost like the cottage industry of the prior to the first industrial revolution. Bespoke means I've got a shop, I've got all the tools all around the shop. They could be set up in workstations, whatever. But I come in, I do the work, I move from tool to tool to tool, and I slowly work on it. Or I've got a small group of people that work in there with me, and we're all just working as we go. And it's a small, we're not putting out high volume numbers, it's low volume manufacturing, but we're paying high attention to detail. You're going to see Fabergé eggs made this way. You're going to see a lot of Etsy producers work in a bespoke fashion. Now we move to job shop. And a job shop, it's like bespoke. You're still paying attention to detail, but it's going to go a little quicker. You're going to have a few more employees and there's going to be a little bit more organization, but it's still fairly old school, so to say. A lot of mechanic shops are this way, auto body shops. Batch production. This is where we start getting into the larger end of the producing that we're doing. A batch production, we get one job order from a customer and we process that through. We're focused in on that. And so we're looking in chunks like that. Now, repetitive production, where the pace is wrapping up. This is where you start seeing conveyor belts coming into play and the production numbers increasing. We want our quality to be high, but we're not spending a lot of time on every little detail like you would with the Fabergé egg. And then continuous production, which is number five. And you're going to learn that this is like these last three. This is what we think of when we think of manufacturing nowadays with larger plants. That's going to be your batch production, your repetitive production, and your continuous production. I grew up in carpentry, and my dad was a framer. Then he went into making furniture. And when I helped him in his shop building furniture, it was bespoke. And that's what we did, high attention to detail. We wanted a high quality product, and we were selling it to customers that were willing to pay a lot of money for oak furniture with great detail. So that's going to be your introduction for this week. And this week I am going to post the slides. I'm going to go and do that today. But bear in mind, I may be doing some revisions of them still tomorrow. So if that occurs tomorrow and Wednesday, if that occurs, then I might update with the announcement um, with a more current rendition. If you have any questions this week, feel free to send me an email. I'll look forward to them. Remember that anything you deal with that has any sources, anything you use that has a source, you must use APA 7 for your citations and for your references. This includes discussions. If you're giving if you're talking in your discussion and you're using material from even the material you receive on Canvas, that you can very easily cite that using APA 7. As a matter of fact, all you got to do is look at my reference, my last slide in my PowerPoint presentation here, and you can see exactly how I use APA 7 to reference these items that are in your module. Like I use operations one this week in my slides, and I have it right there. The author is Clear University. It's the publication date is ND, no date. I have it right there. Sometimes you can do that. Look at your professor's slides. Use those. Because if I'm willing to put them in my slides, I'm willing to accept them in your work too. A little trick right there. Um, so thank you very much. And remember, every reference must have at least one corresponding citation. Otherwise, why include any references? You have to cite to your sources. And every time I refer to something, I include my citation. If I refer to it in 15 sentences in a paragraph, then I've got 15 different citations. That's just how it goes. It may sound repetitious, but it sure kept me from getting charged with plagiarism when I was in grad school. And if it kept me out of trouble there, it can keep you out of trouble here. So have a great week. Let me know if you have any questions.